Good morrow, lads and ladies. Brad the Guitarologist here. We have a box here.
Show you with the box. What was in the box?
It's a box. It's on the desk and it's a box.
What's in the box?
We're gonna open the box. We're gonna examine the contents of the box. We're gonna repair what's ever in the box.
What's in the fucking box?
Okay, so inside of this box we have a couple of pedals. One of them is an Ibanez PT9 phaser. Owner said it didn't work. I guess we're going to try to figure out why it doesn't work. Got another one here. This one should be a little bit more interesting to those of us who like more vintage-y stuff. It's a Big Muff. I'm not sure how old this one is, but it looks like it might have a little bit of age to it. Might have a little bit of age to it. It's definitely got some scarring, like it's been around the block a couple times. 50, 57, etched into the steel and also printed up on a little sticker. 50, 57. That doesn't mean anything to me at all. This sure does look like it might be an old one though. But anyway, we're gonna check out the Big Muff and the Ibanez phaser. Probably start with the Big Muff on this one. We'll leave the phaser to maybe another one. But in this one, we will take a look at the Big Muff first. This will give you a good look, though, at what the bent-up backs of these pedals are supposed to look like. In another video, I'll put a link up here if you want to check that one out. I had to actually make a back for a Muff Fuzz pedal. Then I made it here on the bench out of a piece of brass, but this is what the original ones would have looked like. They've got like this kind of, I don't know, this is like a plasticky kind of a coating. Rubber, maybe a little bit of a rubberized coating over the steel. And it's definitely steel because we've got a little bit of rust there. Tells you it's steel. It's painted on the inside. 3003. This capacitor is Mexican. I'm not sure if they would have been made in Mexico on the original ones on that capacitor. Probably would have been USA, would be my guess, on the 70s ones. 3003 on that. There's not much to these things. I mean, not much that can really even go wrong. It doesn't have an integrated circuit. It's got discrete silicone transistors in it. You can see those poking away in there. Let's go ahead and, first of all, as with all pedals that use a 9-volt battery, let's plug it in and just see what it does as is. Plug it into the little bench amp here. We're getting throughput, but when you hit the switch, nothing happens. First thing to check usually is power supply. 12.9 of 18, and it's a Sunbeam. Yeah, I don't think so. I very seriously doubt that. So let's get a new Sunbeam. The reason I scoff at that is because these Sunbeams are pretty much the cheapest you can get for batteries. But you know, they do work. They're okay. You know, I've had decent luck with them actually. Let's see. Okay, still nothing there. Still nothing there. Let's see. Do we have an issue with the power getting where it needs to go? We got a switch here. Not sure what the switch is. Alright, let's test the battery. Or better yet, let's just get the bench power supply and remove the battery as a variable altogether, and we'll put 9 volts on it and roll with that. What do you say? About 9.7 volts or so. That ought to do it, right? Oh! Oh, that just came right off. Well, that battery might not be good after all. Let's So that was the one I was putting in as a replacement, and the terminal just came right off in there. Like I said, cheapest of the cheap. Well, that's not good, is it? That's not good. Get that thing out of there. All right. So the big one on the receiver is the positive. Nope. Yeah, it's acting like I can hear a little bit of something. Like, I think that's the through position. And that is on, but nothing is happening when it's on. Let's go ahead and pop the those off of there. And we'll get our little handy dandy rocket sockets. Love these things. Really cool. This fellow in New Zealand makes these rocket sockets. Check them out. He sent me several free sets of these. I gave some away, and I've kept a couple for myself. So that when these wear out, I'll have some replacements down the road. And when those wear out, I'll probably buy some more off them because they're really cool. They're just super easy to use and very quick. All right, we are probably, I'm guessing. What's your guess? Guess our from the outset here. What are we going to be looking at for a problem here? I'm thinking we're going to be looking at dead transistor. What do you reckon? Dead transistor, or is it power supply related? Vote down below in the comments. Okay. You gonna come out of there or not, dude? Come out of there or not? What's holding me up here? Is it? Oh, it's that pop right there. That pop was holding me up. Okay. One thing I do notice, this little power jack right here. Okay, this is a shorting power jack. Before we go any further with this, right there, that little power jack right there. So this jack, here's the way this works. When you plug an outside power supply, like from a wall wart, into it, that gets pushed down, and you can see that it gets pushed away from this little bent piece right here. See this piece? When something is plugged into this gets pushed down, and those two pieces separate down there. See them separating right down here? See down there? The problem is, I don't think it's coming back up far enough. I believe we're going to find that is most likely the issue. Let's go ahead and test that theory before we go any further with this, because I believe we're going to find that's the issue. We're going to bypass this, and we're going to go straight to. We're going to go straight to here with the positive. Hear that? That sounds to me like the sound of fuzz. So the positive voltage has to go through this wire, right? The red wire, down to here. It has to go through that little shorted jack, then through this little resistor to this terminal. Then from this terminal, it has to be switched in the correct position and jump over to this terminal and make its way down to here. So this is the positive right here on the board. we're gonna bypass as much of this crap as we can and just test from right here. Okay, that I believe is the throughput. Look at that. There's the tone. There's the input. And the volume's working. The circuit seems to be working now. Although it doesn't seem that loud. The volume is working. And the tone is working. Hear that? Let me turn it up a little bit so you can actually hear it. See, this is the problem. It's really quiet, which leads me to believe that maybe, yeah, maybe we've got a bad transistor also. With as loud as that is, that should be blasting us really out of here right now. If I bypass it. See, I mean, that's... It's acting like we're only getting like half of the circuit working. Or something, you know? Yeah, something not right. Well, I mean, it's good to know at least somebody's home, but certainly not everybody is home. I think the next thing to do, we'll take everything back apart like we were doing earlier. But this time I want to prod around and see if maybe something's loose. I don't see any loose solder joints. No, I don't see any loose solder joints, so it's not that. I believe we've got a bad transistor, or maybe, you know, maybe a bad capacitor or something like that. Oh, I wanted to point out while I'm doing this, I wanted to point out some new additions to the bench here. I've got some little guys that little sculptures that my 6-year-old daughter made. She made this guy. He's kind of, some of his little spikes have fallen off because he, when he cured, he kind of dried up and some of the pieces separated. But she's not prompted to do this kind of crap either. She just sits down with some modeling clay and just starts doing it. I'm really proud of her. It's kind of cool. She makes these little monsters, and she makes a little, whoops, little thing I'm gonna break. My little heart daddy thing, and then I guess some kind of little landscape rock for him to live with. I love it. They're my little friends now, man. They hang out with me. And it looks like these are all BC 239s. They are all the way down the line. We've got some disc capacitors for the most part in here, which is good. We do have that blue capacitor back there. And then we've got a couple of black ones. Now, that doesn't necessarily mean anything, but it could mean that the black ones are a later replacement. You saw older pedals tend to have these kind of cosmetics on the capacitors. The blue, that's kind of an older style. You don't see a whole lot anymore, that baby blue color. Now most of them have gone to black, so that leads me to believe maybe these two have been replaced right here. It's kind of hard to say for sure. Well, those are 50 volts anyway. I don't think they would have put 50 volt capacitors in there originally. 16 volts more like it. That's probably original. These are probably not. And so first and foremost, I'm gonna check those to make sure that those are soldered in correctly in the right orientation, because like I said, they've probably been changed. And I think rather than poking around in the dark on this, I will go ahead and grab a schematic. Alright, I got a schematic pulled up off the camera over here. I'm not going to go too in-depth over the schematic right now. We might look at it a little bit later. Right now I just kind of want to trace out what's going on with this. That should be a 15K, right? Where is R6? 15K. Alright. R4. 3.3K, and that looks correct. I'm going to check this whole row of resistors first and just knock these out, making sure that all of these are correct. This is an older version. This is like a 1976 probably, or 77, with that BC239C transistors. This is like version 3 or something like that, according to what I'm reading online. It's not the earliest one, but it's one of the earliest of this particular cosmetic style. The earliest one were the ones that had ram's head, and they were just all silver on the face with a ram's head on there in the logo. But this one doesn't have that. It just has the Big Muff Pi. Okay, so at this point I go through and I test every resistor in the pedal and compare it meticulously to what's on the schematic, and I determined pretty quickly that none of these are shorted or drifted or out of spec or posing any sort of problem. So I decided to change tack, and we are going to start signal tracing here, beginning with the input. Okay, signal comes in. We're going to trace the signal. Signal comes in, goes here, and then goes there, right? Yes, goes right there. That's wrong. I think that's just wrong, isn't it? It's too large. It's 10 microfarad. It's supposed to be a 0.1 microfarad like this. That blue capacitor that I pointed out earlier, this one right here, that's a 10 microfarad capacitor. That is just after the R2 input resistor. I'll put up on the screen what I'm talking about. The R2 input resistor is right here. That's that guy. Alright. That connects over here to this capacitor directly, which is a 10 microfarad. Furthermore, it has the negative side over here on facing the resistor, and the schematic shows the negative side of the capacitor, if polarized, should face the other way. I mean, I'm not an expert of these pedals, but I mean, I do know how to read a schematic, and that's not to the schematic. Let me look this over a little bit more. Okay, back with this thing. I've got the power supply hooked up, 9 volts coming in, bypassing the jack, also bypassing the on-off switch. Got a signal coming in. Let's go ahead and put a signal in, and then I'm reading it on the scope. So it looks like a bunch of noise. Bunch of noise. We're getting a tone, but why are we not registering it as a tone here? Okay. Why is it looking like that? That looks terrible. Focus off? No. Well, let's hook this thing up to power ground. Right there. Okay, and let's actually probe it. Let's probe through the circuit. Let's probe, let's see. Alright, we got something there. It's a little bit fuzzy looking. I've got this kind of enough where we can test it here, I think. So I've gone past the first resistor, the first capacitor, which is that 10 microfarad we were unsure about a minute ago, and now I'm looking at the base of Q4. We're going to come off the base and look at the collector. This is what's coming in. You can see it right there. We've got a little bit of cloudiness because we've got some, I don't know what's up with that. Just a little bit of, I really don't know. So I can move this around and some of that goes away. So there's that. We could trace the signal through though. So there's the signal coming in. Signal comes over here to the other side of this resistor to this point, and we should be able to notice a reduction from here to here, and it does reduce some. Okay. Then we go through a capacitor to the other side of this capacitor. And then it goes to the base of Q4 right there. Alright, so we're still pretty good right there. Let's look up some power at this point because I want to see what happens when we get the power to it. So we want to go we got nothing coming out of the output at all. I don't know why it's showing me this garbage. It's just showing me a load of garbage right there. Well, very interesting. Okay, so I've hooked this thing up to the power supply. I have fixed this little jack right here, so I've got power going through the jack now. That's the little power jack going through the switch. I'm going to trace from the beginning, and we're going to look at the scope. So this is what the signal looks like coming in. You're going to get, I'm getting some noise, and there's not a whole lot I can do about that. The grounds aren't really perfect right now. I've got the nuts just kind of loosely fitted on here and stuff. It's just not, the ground's not great. So just ignore some of the noise that we might see. For now, we're just looking basically at whether or not signal is present. We're not looking at the quality of the signal so much. So we've got signal right there coming into the input. See it right here on the jack. Coming off of the jack, it goes down here to the board right here. On the other side of this resistor, it should diminish, and it does. So it goes from being right there. Make it a little bit bigger so you can tell. It goes from being that big, and what we're looking at is right here. It goes from being here to there, down to there. So that's what we expect. Then it goes through a capacitor from here over to here. It's not going to diminish the signal really, but it does get us through the capacitor over to here. Now we don't have any amplification turned on right now, so it's not going to skip across this Q4 transistor yet. So what we have to do is we have to turn on the pedal. You can see there we get just a lot of interference and noise and stuff going on. It doesn't like measuring right there at the base of this first transistor when it just really doesn't like doing it. It just gets a lot of interference, and I'm not exactly sure why. I couldn't tell you, but I just cannot get a really pretty signal right there no matter what I do. I can come up here to the board. It seems to get a little bit better, I guess, if I ground over here as opposed to on the chassis. So we go from there to there. The chassis is even worse. But skipping up here does look a little bit better for now. I guess we can use that for a second. So this is going to at least allow us to see their signal there, and then we should get a bigger signal that goes from here, right, at a peak, up to way up off the scale. So our first transistor is working, and it's working nicely actually. That's what we're looking at on the collector. Beautiful wave on the collector of that. Okay, so then it goes, well, it goes a couple places, but we got some feedback going on through some capacitors here. But if we follow the signal on out, we should go through a 1 microfarad capacitor. That will be this guy. So let's go to the other side. Hang on. Yep, picks up here and goes right here. This is the other side of that 1 microfarad capacitor. So there's one side of the capacitor. Here's the other side of the capacitor. So we got signal there. Goes up to this point. We got signal there. If we follow that around, it goes to this pot. Why is that so squirrely? This probe is not good. Something's not right with the probe. It's really really squirrely right here on this probe. There we go. That's it looks a little bit better, doesn't it? All right. So this is the pot for sustain. And if I go to the other side of the pot, you can see this pot's working. Okay, so we're good all the way up to that point. Sustain pot good. Now we're going to see coming out of the sustain pot a 0.1 microfarad capacitor. So if we trace that over to find that 0.1, we will see it goes from there to here. So from there to here. That's our 0.1 capacitor. Then it comes around and should go through a 10K resistor. And it does. It goes from there over to here, which is also, it corresponds, let's see, from there, 10K resistor from right there. Let's do this again. There to here. Why does it get so ugly right there? From there to there through a 10K resistor? Is that all that's doing? I mean, I know it should diminish the signal, but should it make it that ugly? Look at what it's doing to it. Okay, should it? I mean, I know it's going to diminish the signal, right? We're going from a nice, pretty wave, though, to something that looks a little bit distorted as well. So if we make that a little bit bigger, you can see it's rounded off at the top and the bottom. It's kind of smeared. There's definitely some distortion or something going on there. Again, it's going to be kind of hard to do a direct comparison. But that is kind of what we're looking at right there. And that is the correct one. We'll see brown, black. So that's 1 0 and then 3 zeros. So that's 10K. So I'm thinking something in the feedback network maybe is off on this stage, possibly. But let's go to the collector. So if we go from the base up to the collector, we do see an increase in the... Whoop, what have I done again? Okay. From the base... Wait, from the base to the collector, we see an increase. It does clean up quite a bit. We see an increase of signal. From there to there. I don't know why the signal would smooth out as much as it is. Well, that's when the clipping diodes are being introduced into this stage. I get that. So that might have something to do with it. So we should expect probably that signal to be clipped, I guess, right there. And it is clipped. You can see that it's clipped. And then it amplifies coming out of that stage, and you can see that it's clipped. So, I mean, what I mean by that is it doesn't look like what we started with. It doesn't look like that. You see how that's kind of a rounded off signal? That's coming out of the collector of the previous stage. But this is what we have here. So a difference between this and this. That's more of a clipped signal. So we're moving through okay into this stage. So coming out of the collector of Q3, that's where we are right now. We should go through another 0.1 microfarad capacitor. That's C13. We have to find that. It's going over to here. Yep. It's going from there to there. right here, and you can see how clipped that signal is. I hope. Okay, and then we got a resistor from this point, which is what we've gotten up to. We've got a 10K resistor coming over to here. And that's going to drop, again, that's going to drop the signal way down. So we have to amplify that on the scope here to see it. And it's really smeared yet again. And also that's going to go into the base of Q2. So we're down to Q2 at this point. Here's the base. Go over to the collector, and it does not amplify. Look at that. Q2 base, Q2 collector. It is not amplifying. So something in Q2 circuit is off. If it's not Q2, it's going to be one of the surrounding components of Q2. It's going to be C11 or C7. We've already checked the diodes in that circuit, so it's either R, and we've already checked the resistor, R15, R16, and R10. So if it's either Q2, C11, or C7. So let's go on that assumption that it's one of those three components, and maybe we can track this down. Alright, so I've pulled the board again, and we can look at what we suspect to be the problem here. The problem is somewhere right here in this Q2 circuit. So it's one of these guys right here, or Q2. So we're going to pull to Q2 and test it. The reason to test stuff like this out of circuit is it'll often give you false readings in circuit because you've got, especially when you've got a couple of diodes that are already in this circuit. I mean, I just know from experience, I don't know if this particular circuit would do this, but some transistor circuits will definitely give you some false readings when you're trying to test transistors in circuit. So with that pulled, we'll see what we get. Okay, it's testing as an NPN transistor. So that's not it. Man, I sure would have bet money on that being it though. Okay, so I've pulled C9 also. C9 is it looks like it's a coupling capacitor into the tone knob, or it's part of the tone. What is it? What is C9? It's a part of a high pass filter. Reduce this cap for more mid-range notch. Increase to 0.004 for less mid-range notch. It's going to give you, I mean, it's part of a tone circuit, but we're testing it just to make sure that it's not shorted or something. And 5607 picofarad, it should be 4,000 picofarad is 0.004. So it's high, but that's not a huge concern. Consider it's gonna maybe change the tone sweep slightly, but it's not gonna cause the problem we're seeing of exceptionally low volume. Okay, and here is C11, and C11 is supposed to be 560 picofarad. That's the one we were measuring, like 800 microfarad. Yeah, we're within tolerance on that. 624 picofarad. So that's not the problem. What do we got left? Diodes. I did already test the diodes. I did not pull the diodes and test them, but that's about it from what's in that circuit. R16 maybe. I could retest the gosh, I don't know, guys. I don't know on this one. This is a puzzler. Okay, so I needed to retest these diodes, D2 and D1. Problem is, when I pulled D2, one of the legs, I was trying to pull one of the legs out, it just snapped right in half, and it didn't take much effort to do so. So I don't know if it was already cracked or what the deal was. but it definitely snapped in half really easily. So I'm gonna have to replace D2, and D1 I just tested. It's still intact, and D1 doesn't seem to be good. It's not testing as a diode. Let me test it again with my other tester here, just to make sure. I tested it with my fluke just now, and it did not come up. So let me see what's going on with that. And what I'm going to have to do is get as close as I can to this style of diode, because we don't, we don't want to change the, we don't want to change it too much. No, it's coming up as a diode. Why is it not? Why didn't it? I'm not sure why it didn't come up on my fluke though. Why didn't it test as a diode on my fluke? Let's try that again. Right there, it should. Wait. Whoop. Oh, it's testing. It's testing good now. There it goes. Well, why did it not test good a minute ago? I'm kind of trying to move it around, and anyway, seems fine. D2, like I said, cracked in half when I was trying to get it. I was trying to pull one leg up, because really to test these diodes, I would like to have at least one of the legs out of circuit so I can make sure I'm testing independently this diode and this diode, and there's nothing else in the circuit. So I'm not testing, like, for instance, one of the directions. I'm not testing the NPN transistor from, like, base to collector, for instance. What have we got here? IN914 on the schematic I'm seeing online, but this one looks like it has a 41 on it. That looks like a 41. I'll look at these over here. Let's see. That one looks like it also has a 41, and then this one over here looks like it has a, I don't know. I'm gonna have to get my, let me get my microscope on it. Okay, so according to what I'm seeing on the microscope, this looks like it's a 1N4148. I had to look up online the 1N914, and as soon as I put in 1N914, it came up with 1N914 versus 1N4148. Apparently, one of those replaced the other back in the day. But the 4148 is what was in this. So they're not hard to come by. I'm going to order up some of those, and we'll replace them. But unfortunately, that means I'm going to not be able to probably troubleshoot this at the moment. I suppose I could stick another diode in there just to see. Alright guys, we're back with this Big Muff, and I spoke to the customer on this. I probed around, and I went through this entire circuit. The initial complaint was that it would come on only intermittently, and I think we explained that with this little connection on the switchable power jack right here. So that right there is, I mean, it's still kind of corroded. I bent it back into place, and it's getting good connection right now. I'm going to go ahead and try to clean that as best I can. That's a really hard jack to clean at the end of the day, but we'll do what we can with that. But bottom line is, it's working now. There are no bad components in this. It is just low volume at the output. I scoured the internet as well. If you type in a Google search for Big Muff low volume or low output, if you do a Google search, it's a very common problem apparently with these. The first 2, 3, 4 generations of this pedal, that some of them just ended up having low output, to the extent that the output, when everything is cranked, you can have the volume, the sustain, the tone. I mean, it doesn't matter where you put it, the volume will be lower than the throughput volume if you turn the pedal off. So it's weird. It's like it drops down below what you would expect something to be that had 4 transistors in it and run by a 9-volt battery that should, by all measures, be it should be louder at the output, you would think. I didn't measure that many resistors that were even that far off. I mean, there might have been a couple of the supply resistors for the collectors on these transistors that were a bit, maybe a little bit off, and that might have, you know, shifted things some. There might have been some grid leak bias, or not grid leak, but excuse me, the base bias resistors that you know, were maybe slightly off, lower than they should have been. So what I did was I contacted the customer and asked him. I was like, "Hey, you know, this thing is working. You know, it's working to the extent that it probably always did, or has at least in recent years. But if you want, I can probably improve this." And he gave me the okay to do what I can. I'm going to go through it, maybe change a few values here and there to try to increase the output. It looks like it's a common enough issue that this, you know, maybe if we go through this and we're able to solve it with a few changes, maybe that'll give some other people some direction on how to, you know, fix similar problems with theirs. So I imagine we'll be using these quite a bit, both of these boxes, and we'll, I mean, you know, I don't know what else to do. I mean, I could send it back to him as it is, but honestly, this thing is, it's kind of disappointing, to be honest. You know, you would think that a 70s Big Muff that was operating as it should, all the transistors, they're testing good. You know, that's about what I can say for them. Now, are they amplifying to the extent that they originally did or whatever? I suppose they are. But I really don't know. I would assume that they are. I mean, I don't know that transistors would really diminish over time. I don't know that I've ever heard of that. If there are some that do, these might be some of them. But I don't think that that's a thing that I'm aware of. I've never heard of that. Transistors, usually, it's either good or it isn't, in my experience so far. I'm going to go on the assumption that the transistors are not the problem, that we've got some surrounding components maybe that have drifted slightly. We're going to change some stuff to try to beef up. At every stage through this thing, we're going to try to increase the gain and the signal going into the next stage. So, yeah, let's go through it like that, with that in mind. We're going to adjust R6, which is the collector resistor for the final stage. And by final stage, I mean the Q1 stage. So we're going to take that from 15K and probably adjust that up or down. I'm not sure which exact way we should go with it. Probably up to try to increase the boost from this final stage. We have just a 1 kilohertz sine wave going into it right now. Okay, there's the throughput. There's no R6 right now, so we are going to. We'll start at the standard value, which was 15K. So we'll put this on 15K and start it up. Okay, so there's that. See how loud we can make it. Well. So somewhere between 22 and 33 it cuts off. You can hear it get louder there. Switch over to 15K. Put something under there to keep those pots up off of the chassis. You know what? I want to try something above 22 but below 33K. Nope, too much. 22 might be the limit. So there's that. Or this. Wait. Oh yeah, there's a big difference actually. Big difference between those two. So that is going to help. I'm actually so glad that he said go for it. You know, a lot of people get really persnickety about these kinds of things. I mean, old pedals and old amps and stuff like that, and they don't want to do anything to them that will, you know, make them more useful and make them a better unit. You know, I'll keep all the other components that I take out. I'll keep and, you know, put in a baggie for them. But yeah, I just see no reason to be so finicky about this stuff. You know, it's here to bring enjoyment and to make your playing better. You know, and if it's not doing that, if it's not sounding its best, then I really don't see the point in keeping something original or stock if it's not doing what it should do. You know, if it's not at least louder than the throughput signal, to me it's useless as a boost. Because you should, when you step on a pedal like this, you're going to you're going to a louder part of the song usually. You know, you're going to a raunchier, louder part of the song. And if it doesn't kick in and do that, and if it can't overcome, you know, everybody else also doing that in the band, then what's the point? You're losing your feeling in the song. You know, there are some people I've seen that do overcome this limitation using other pedals in their chain, and I mean, that's one way of doing it. They used like what was it they were using on this one thread? Oh, an LS2. They were adding an LS2 or like a radial ABY box switch, and using that in such a way. You can go and find threads about this and people talking about it. I'm not really much of a pedal guy, so I don't even bother with that kind of stuff usually. I mean, if you want to do that Smashing Pumpkins kind of stuff, you got to have this pedal. You know, a lot of that 90s alternative and grunge and stuff was using this pedal. Dinosaur Jr. A lot of the lo-fi 90s stuff was using these pedals. They were a heck of a lot more plentiful back then. They really weren't as collectible as they are now. You know, they were just a pedal. I mean, it's not that people didn't spend good money for them and stuff, but they were nothing like they are now back in the 90s when I was first started playing. Okay, so there's that one. Let's see what else we want to do here. Okay, the next resistor I want to look at is the R7 resistor, and that acts to supply bias voltage to the base of Q1 along with R3. Together they act as a voltage divider, and R7 should be up here somewhere. Is that it right there? I think that's it. Alright, there's R7. Some of these components, they've got the legs of these resistors kind of laid across one another, and it's kind of hard to see which is which, and you just gotta be careful you don't mess up the trace when you're taking components in and out of it. Okay. Alright, now where's that going? That's going right to that leg of the transistor, so we will put one lead to this leg. That is the base. Okay, so we've got one lead going to the base of the transistor now through the selector here. We'll start where we started, which is 470K. Let's see what this does. Let's put the signal back in. There we go. Let's adjust this resistance and see if we can make this louder. So it cuts off that way. There, see, you can take it and completely cut into cutoff. That is the distorted signal, right? I'm pretty sure it is. Yeah. So there is the throughput signal. And there, see it's still dropping down, which, I mean, we may not be able to fix it from dropping down somewhat, at least. But we're going to do our best here and see what else we can do. We'll go back. We're working at the end of the circuit, and we're working our way backwards. So let's put that resistance back in. That's not really going to affect anything, obviously. So, okay, our next stop along the line is going to be R4, which is the bias. It's resistor for the output stage that comes off the emitter to ground. And that will be right here, R4. This is the second one from the right. Let's get our power hooked back up. And let's get this ready to something around 3.3K. So apparently this one is going to be real subtle. And this may be more subtle than what we can use with this. We'll try it with this and see what happens. Okay, that's the throughput signal. This is the distorted signal. And okay, 3.3K is seems to be about as loud as it gets. I think I want to go a little bit lower than that, maybe. What do I have? Try 2.7 now. Nope, we went too far. All right, I'm gonna add more resistance to that. That or this. The one that's in there surely is the best, is the better one. Okay, so there's that one soldered in right there. We changed these first two resistors so far. Now we're going to move down here to R11. That is 1, 2, 3, 4. This is the sixth resistor from the right. And currently it is a 15K. That is the Q2 collector resistor. There we go. Same thing, except this time I'm going to try to use the box again. Really? That's odd. That's making absolutely no difference. That's making absolutely no difference. Look at this. R11 is completely disconnected, so Q2 is not even biased on. So why? What is going on with that then? What the hell, man?
It is quite a three-pipe problem, and I beg that you won't speak to me for 50 minutes.
Okay, so here, look at this. So, touching Q4, that's introducing a lot of noise, like you would expect, right? Q3, it's introducing a little bit of noise, not quite as much as Q4, which is what you would expect. Q2, though, nothing. Now this is lifted. However, I tested Q2. Q2 tests fine. You guys saw me do it. I tested every single component surrounding Q2, and all of them tested fine. So I just don't get it. Look at that. Look at that. That's 330 ohms. It's sure gaining up now. Now look at the difference between, that's what this thing is supposed to do. Why did, and look, it's just a very narrow band too of biasing for that. That must be malfunctioning. Q2 must be malfunctioning. because that is way outside the spec for what that should bias at. It's supposed to bias at around 15K, but I got that to do that at 330 ohms. That, I mean, that is huge difference. Okay, so here's the regular value that it's supposed to be. We'll go put on 15K. Here's what it's supposed to be. You can barely hear it. It's almost non-existent. And there it is, kicked in. You can barely hear the fucking thing. I may stick this one back in for just a second and tweak on R10. Okay, so R10 is conveniently right beside the one we're messing with right now. That's this one right here. That's R10. And that is a 1, 5, and a 1, 150 ohm. Let's measure a negative 280 ohms. We'll measure it out of circuit. Something came alive right there when I pulled that. I know I measured that. Yeah, it's 150 ohms. Wait a second. That's with nothing. That's with nothing. That's with no bias at all on that. That can't be right. So that's, if there's no bias at all on that and it's that loud, then there's something definitely wrong. Definitely wrong in that circuit. There's just gotta be. It's gotta be that transistor. I don't know why I'm still screwing around. I mean, it tested good. That's why I'm still screwing around with it. I'm trying not to replace his original transistor, you know, out of the thing. But I think we're going to have to. Because look at this. Right now, this is connected to nothing. Look at this. These two resistors are completely pulled up and they're not replaced with anything. Okay? And it's already far louder than it was. Far louder. That's the throughput. And this is... I mean, what the hell? I've never claimed to be an expert in pedals at all. And this is one of the frustrating things about transistors to me, is that it just... They seem to do wacky stuff every time I have something with transistors. They always seem to do wacky shit. And I'll be honest with you, I just don't get it. Because that tested good, but it should not, it can't be good. It can't be good because it shouldn't be doing anything right now. It shouldn't be biased on at all. There's no R11 and there's no R10 even in circuit. There is no resistor from the emitter to ground, and there's no resistor from the collector to the 9-volt source. I think my first hunch that there was a transistor bad in this is probably correct, and I am thinking it's that one right there. I'm just going to replace that son of a bitch and go on with my day here, because I'm pretty sure that has been the problem all along. Let me see what I've got in my transistor stash that will get as close to as possible. Okay, so I've got that transistor just tacked in there for now. That is a 2N2222. and it's just a general purpose transistor. We're just tacking it in. It has to go in backwards. It's a little bit of a smaller package than the old one, which was made by Fairchild, by the way. I just looked at the data sheet on it. At least it's being affected now. There we go. Like I said, that's just tacked in. But see, now it's being affected by this. At least it's having an effect, which was more than we could say for the other thing. Okay, I dug around in my stash, and it looks like I've got some BC549s, and these are very close to the original 539s. They're about the same size package and everything. Very similar. We'll solder it in, and then we'll bias it up and roll with it, I believe. I've got the Q2 wired in. Now I'm going to do one more mod, I think, on this and leave well enough alone. I'm going to change C1. That is the input capacitor. It is a 10 microfarad, pretty big. I have seen schematics online. Most of them have 0.1 microfarad going into that first stage. Some have like maybe 1 microfarad. I saw one schematic with a 3 microfarad, but I didn't see any with a 10 microfarad. That is a very large capacitor going into that, and it's contributing to a lot of bass in this circuit. You have to turn the tone knob way down to get what you would consider, something that has some decent mid-range and would cut through a mix. Most of the range of that potentiometer, the tone, seems pretty useless, and I think it's really down to all of the bass that's being put into the input. And plus, it should crunch up a little bit more than it is, and I think it's also down to too much bass on the input. It's just a little bit on the muddy side. I mean, you want some bass. That's what makes a Big Muff a Big Muff. All the bassiness to it. You want some of that, but you don't want quite that much. All right. Okay, just messing around with it. I think I can see why that first capacitor is a 0.1, or it's somewhere in that range, and not a 10 microfarad, because that is way better from what I can tell. It's just got more crispness to it. It's way less muddy. You can get just that sort of mid-rangey drive that you kind of expect from an old Fuzz. It makes a lot more sense to put a 0.1 in there, which is exactly what I'm going to do. Alright guys and gals, that'll just about do it for this video. Before we get into the demo portion, I want to make you aware I did make a clone of this pedal just like we did with the Muff Fuzz the last time I did a video like this. I couldn't resist and sort of made a bit of a clone of this thing. You can see a sneak preview of what the clone ends up looking like. It's sitting at the back of the desk. If you want to see a video on the making of that clone, I will put links in the description or in the upper right hand corner of your screen. For the demo portion, I went through the bench amp that I use, which is a little Dinosaur amp. I did add a little bit of just a tiny bit of distortion on the Dinosaur amp, not very much at all. I mean, it's just kind of overdriven slightly, and that's probably where you would want to run this anyway. Usually with Big Muffs, you want to get the distortion of the Big Muff on top of your amp's distortion, and that really sends this thing into like a screaming kind of overdrive, singy lead sounds that you hear on a lot of those old records. But anyway, for now, let's get into the demo portion, and we will see y'all later.